Go ahead and pull up your homework problems for 7.5. We went through these yesterday. Let's do some of these down here. Let's do number 21 and 23. We'll do that together, okay? Say it again. This is for 7.4. 7.5 is next. That's got the two parts. Let's look at 21 and 23, guys. All right, so for 21, we have to have a common denominator, yes? In order to be able to add, guys, I need you to stop talking, please. In order to be able to add or subtract rationals, fractions, you have to have a common denominator. So look at 21. What are the two denominators that you see? X plus 4 and X plus 6, right? They're both different, so how would we get a common denominator? We're just going to multiply them together. So I have X plus 4 times X plus 6. If you guys want to go ahead now and state what the denominator cannot be, that's fine. What are the two numbers that the denominator cannot be? Can't be negative 4 or negative 6. Because if it is, at any time, it will make your rational become 0. I mean, the denominator becomes 0, so your rational becomes undefined. So now we look and we say, okay, what does each fraction have? What is it missing? The first fraction has the X plus 4. What is it missing? The X plus 6, okay? X plus 6. The second fraction has the X plus 6. What's it missing? The X plus 4. Now watch, guys. You got to be careful with subtraction. So you have 3 times X plus 6 minus 1 times X plus 4. That does not say minus X plus 4. It says minus X what? What do I have to do with this minus sign? You have to distribute it. If you have more than one term, I would keep everything in a parenthesis and then remind yourself, ooh, hey, I have to distribute this. So now we can simplify a little bit. Let's distribute this 3 first. So you have 3x plus what? 18 minus x minus 4, because we distributed that negative sign. And then I have x plus 4 on the bottom and x plus 6. So let's combine like terms. What's 3x minus x? 2x. And then what's positive 18 and a negative 4? What's 18 minus 4? What is it? So plus 14. Yes? Okay, over x plus 4, x plus 6. Now, is that completely simplified? No, it's close. What can I take out of the numerator? I could take out a 2. This becomes x plus 7, and then over here, x plus 4, and x plus 6. Can I simplify any more? Can I cross anything out? Is there anything exactly the same on top and bottom? No. A couple of you lost some points on your test because you got to this part, and then you told me that x couldn't be 4, or negative 4, couldn't be negative 6, and it couldn't be negative 7. Can x be negative 7? Yeah. Is it okay if your numerator becomes 0? Yes. It's the denominator that's the issue. All right, let's do 23. I'll let you guys do the last 3 on your own. I'll let you do 19, 20, and 22, and then you'll be good to go. So I have 12 over x squared plus 5x minus 24. X squared plus 5x minus 24 plus 3 over x minus 3. All right, what's the first thing we should do? Before you even try to get a common denominator, what should we do? Factor. Let's factor this denominator. What times what will give me a negative 24 when I multiply, but a positive 5 when I add? Plus 8 and minus 3, okay? So now we're going to find a common denominator. Whatever is different, guys, you just stick it down there. So what does the first fraction have? It has an x plus 8, and it has an x minus 3. What's the second fraction have? X minus 3? All right, then we don't have to put it down there. We already have it accounted for. So our common denominator is x minus 3, x plus 8, however you want to write it. So go ahead and tell yourself what x cannot be. What are the two things x can't be? Positive 3 and negative 8. Perfect. If x becomes those two numbers, then your whole rational becomes undefined because the denominator will be 0. So now let's look at what each fraction has and what it needs. If I look at the numerator and the denominator, let's compare. Do I need to multiply, God bless you, anything here to make those two denominators look the same? No, it's already fine. So we're just going to write the 12. Plus, my second fraction has the x minus 3. What is it missing? The what? The x plus 8. Good. So this is 3 times x plus 8. Perfect. Can I just go ahead and cross out the x plus 8s? No, I cannot do that yet, guys. You got to combine like terms completely, distribute, combine like terms, then see if anything cancels. So I'm going to distribute this 3 here. I have 12 plus 3 times x is 3x. What's 3 times 8? 24 over x plus 8, x minus 3. Now we're going to combine like terms. What's 12 plus 24? 12 plus 24, 36. So I have 3x plus 36 over x plus 8, x minus 3. Hi, can I factor anything out? What can I factor out? I can factor out a 3. All right, so factor out the 3. What are you left with? X plus 12, okay. And then I have x plus 8, x minus 3. Is anything in the numerator and the denominator exactly the same? No. All right, so what we're going to move on to tomorrow, guys, we're not moving on to anything brand new. What we're going to do is we're going to take problems like this, and it's going to be equal to, say, 7. So we're going to find a common denominator and then solve. That's what we're going to do tomorrow. So it's the exact same thing that we're doing now. For the next few days, we're going to be doing the exact same thing. It's just one extra step where we're going to actually figure out what x equals. And then once we find out what x equals, we got to plug it in and make sure that it does not become, the denominator does not become 0. Yes, ma'am.
Are we doing 9 through 16? Because yesterday in the notes you had us skip
No, we're finding the least common multiple every time we do this, so it was kind of redundant. You can skip it, that's fine, yeah. I mean, if you want to practice it and just kind of factor it out and see what each has, what it's missing, that sort of a thing, but I think it's just easier to actually see that once you're actually doing the problems.
So we can cross this out?
Yeah. I mean, if you want to do it for extra practice, that's fine. All right, questions?